Okay, recording the session. Awesome. All right, I think I always thought that it's important for you to have a look at the syllabus. I know some of you, the syllabus is already on the Blackboard, and I hope that you guys had the chance to look at it. Let me put this here so I can see the chats. But also it will be good if we can discuss the most important terms. The session will be from 2:30 till 4. Yes, this is usual. Today we may be able to finish earlier, I don't know. So on my calendar, it's from 2:30 to 4. I will try to finish earlier. All right, now what about the syllabus? I would like to discuss the following because I believe they're very important. Description of the lab, like what is it about? The course learning outcomes, because you need to know this. So this is outcomes. When do we meet and where? The grading system and lab reports. How do you believe they will end up being, especially that I believe, although nothing is final yet, that all the lab is going to be online, okay? If you already took the lab last year, I mean last semester, probably you know what I'm talking about. Any newcomers who never ever took physics lab? Please speak up.
I'm a newcomer.
Yes, so
Yes, Doctor. Yes, Doctor. Anna can.
Okay. By the way,
Me too.
this lab is targeted for students who never ever took physics lab. All right. So probably the students who already did physics 306, which is modern physics lab for life science, they're not too many. Okay. All right. Let me start by discussing the description of the lab. You will deal mostly with mechanics. You see projectile motion, motion in an incline, centripetal force, momentum, and collision. Then in the course and in the lab, you will deal with vibratory motion and waves. We will do simple harmonic motion. You will do some rotational motion, and then buoyancy in a liquid. You will study waves in an air column, and I mean by that resonance. And you will do some heat, linear expansion, and specific heat of some objects, mainly metals. So specific heat is basically you have to mix two substances, water and something else, and you will find a way to measure the temperature before and the final temperature, which is thermal equilibrium, and find the specific heat capacity of a certain substance. All these experiments are really nice to conduct. These are my favorite, to be honest. I already have videos of the experiments conducted by me. I will try to do new videos for us, probably to target you guys, all right? My new audience. Okay, the course learning outcome. We know that basically we're trying our best to meet those outcomes through online lab, because you know the lab, most of a very important outcome is the actual experimental work. Teamwork is also very important. Data analysis is very important. You will be surprised to see that data analysis is the main objective of the course more than the physics itself, and you will not be happy about it, because I know you expect to cover physics in physics lab, and that's true. But you will discover that we do a lot of data analysis, and you will be frustrated and unhappy about it. You will say, I'm good at physics, I don't want to learn data analysis. And then you will discover, well, it's all about data analysis, and you will fail the lab. So let's not let this happen. That's why I decided to take a lot of time over data analysis and probably break the syllabus, the presentation of data analysis into two parts. One part will be covered today and another part next week, to take our time through all the examples. If I'm glitching at any moment, please let me know. All right, when do we meet? You need to understand that we are 6 different sections of Physics 302, and I give only the first 3. You are the first one. So officially, we are supposed to meet from 2:30 to 5:30, and that's 3 hours. Basically 3 hours including the work that you will do over the week. Because in the lab, usually you do your own experiment, and you fill in your own lab report, and you will do all the calculations within 3 hours. So us meeting for an hour and a half maximum, I suppose, I hope, will be to cover the whole thing minus your actual work. Okay. Yes, so it says 1 credit, 3 hours allocated over the week. This is the schedule of Monday. This is a tentative schedule though. So you can see we are February 1, we're doing this. I will try my best to follow this one, unless we may need to be flexible for any reason. Let's say you need more time, or we need a revision session, or probably do data analysis today and something along with part 2 of data analysis. So this is a template to follow. So you see you have a midterm around the week of 15, 19 or 22, 26 March, somewhere around these. We will let you know about the exact time and date and how of the midterm. And you see it happens after lab number 6. So I suppose the first 4 labs will be for the midterm, covered in the midterm. That's minimum. And the remaining labs will be covered in the final exam, which is basically the same as the midterm. We actually use a midterm only to give you a chance to try, because we don't want you to try in the final exam and that's it. Now a bit about where do we meet. I'm gonna use the same WebEx meeting for every Monday, same timing. This is my email. Please email me for any question or comment. Also, you can send any message on WhatsApp if it is easier for you. Office hours. You see in the syllabus, there is official office hours that usually I was supposed to be in the lab, in the office, waiting for you. But since we're not going on campus anytime soon, let's say every hour is an office hour for you. You just have to tell me via email, and I can give you an appointment and we can meet every single day if you need to. Okay, please, let's do that. And to be honest, everybody's doing that. Why not you? Please stop me if you have any questions. Is it fine? All right, so these are the main aspects of the syllabus. Please read the syllabus because there is a lot of expectations, especially a lot of things you need to know, the withdrawal, the attendance, but these are the most important aspects. The grading system, midterm and final exam, half, and all the lab reports that are actually 10. You can see here, we have 1, 2, 3, 4, up to 10 lab reports. Introduction is not graded, as you can see. So all the lab reports will be actually 50% of your work. Okay. Now lab reports, how do they look like? You will be given a manual. This is a screenshot of a part of a manual. And you will be given a template to fill in. The template will be given to you as doc and as PDF. So use any app you want to fill in the document. It's very important to write the date and your names. I mean by names, yes, you can work up to 2 persons, 2 students on 1 lab report. I know you're not actually meeting, but I know virtual meetings can happen. If you ever work, and that's optional, you don't have to work with a partner. You can do it alone, because probably, I believe, alone is more efficient and much better for you. If you ever pick a partner to work with, please present 2 lab reports. I mean, I will explain. When you go to your Blackboard, you will see the experiment, which is a video of the experiment. Whatever PowerPoint presentation, lab report doc, recorded session, and submit here the lab that we're doing. You click on submit, and this is where you will have to upload your lab report. You can upload your lab report as doc or PDF, but trust me, if you upload it as PDF, it will be clear to me. The graphs, the pictures, the tables will not move, because if you upload doc, probably your table is gonna look weird and your graph is gonna look, I don't know. So always convert to PDF. It's much better because it will stay on Blackboard as is, because I'm gonna grade it directly on Blackboard. It's not like I'm gonna download it. And you will present only 1 file. I know probably you don't have experience in this, and I'm gonna discover some difficulties you may face. So put everything on 1 file and upload only 1 file. Students in the past used to upload the questions, like in 1 file, and then the graphs in another file, and then the tables in another file. No, this is a lab report. It has to be one document, everything included, neat, Times New Roman, font 12. It's an official report. Okay, now I know this is not official to be given to a patient or to your customer or to, I don't know, your project manager. You're learning how to do a lab report, and this is why please take my remarks very seriously when I discuss the shape of the lab report. Okay, in the past I had to ask the students to repeat the whole thing before grading because it was impossible to read. I think it's not gonna happen in your case, but I'm willing to give you time to submit again and submit again if there are major things you need to modify. So let's say Aya, and let me see your names. I cannot see your names. Okay, so let's say we have Aya and Samir working together on the same lab report. So you put the names Aya and Samir. Aya will submit the work and Samir also will submit the work because it will take me some time to see that Aya and Samir have the same lab report. I don't want Samir to have an unsubmitted assignment. You see what I mean? So every person will submit even if it's the same lab report. And please do not work with a person without writing his name, because I think it's silly for me to correct both lab reports knowing that you did, it's the same copy. Okay, so please don't waste my time. This will help me be like more efficient and faster to give you back your grades, don't you think? All right, you will expect a video. These are screenshots of the video of experiment 1, I think, or 2, which is incline, acceleration on an incline. I know the videos are not great because I don't have a team working with me, and I'm using my phone, which is not a great camera, you know. So I'm trying my best to make it as clear as possible. Let me know if it's not clear at any moment. What else? And that's it for the syllabus. So read the syllabus. If you believe there's like the actual syllabus, if you believe there's some things that are not actually very clear, let me know. Any questions? No?
All clear.
All clear. Okay, next. Now data analysis. Get ready, please, with scratch paper, calculator, and probably an Excel spreadsheet that we may need to use. All right? The outline for today is only 1, 2, 3, 4. I'm gonna do 5 and 6 next time I see you. So we still have 5 and 6 to cover later on. Probably I will modify the same PowerPoint file. Like we can have only 1 at the end. So 1, significant figures, what are they? Probably if you did American high school or the French bac, you know a bit about this. Measurements, how we do measurements, what measuring tools we have, and basically I need to target the uncertainty. 3, averages, why do we do averages? And mind me, we have to do at least one of those in each lab report, so you need to know how to deal with those. So measurements and then averages, why do we do averages? And once we do an average, how do we find the error on the average or the uncertainty on it? We usually call it RMS or root mean square error. And if we ever do a calculation, what is the uncertainty on a calculated value? Okay, this is a lot to grasp. So let me know if you have any question. Okay, significant figures. You need to understand that those digits are significant for many reasons. Some are significant for precision, and some are there only to tell if it's a hundredth or a tenth. So you can simply remove the 0 and put times 10 to the power positive something or negative something. So it's not significant anymore for precision. So we care about precision because this is basically a communication. We're communicating to a patient or to a customer. Okay, so for example, if my child is sick and my doctor would tell me, give her 1 spoon of medication, this is precision something. And if he would ever tell me, give her 1.0 milliliters of something, this is another type of precision. 1.0 milliliters or 1 milliliter, this is two different types of precision. And precision means more or less information. Sometimes more information is very important, sometimes not, because it doesn't matter. So those digits are not mathematical numbers anymore. From now on, those numbers, digits, are measurements. So you always need a unit, and if you don't have a unit, simply write no unit, but don't keep it blank. And whatever the calculator gives you, calculator deals with math. The calculators do not understand measurements. You need to learn how to round things up, okay? I need help, probably. By the way, how about I see the list of names? It would be easier for me to interact with you. So this, and then this. So I can, just a second, yeah. So if you don't know, it's okay. And if you answer wrong, it's okay as well. Probably I can ask Noha. Noha, are you there?
Yes, doctor.
Okay, so 502 grams, how many significant figures do you believe this is?
3.
Okay, because I will count all the digits. The 0 in the middle, I need to count it. So I'm gonna write 3. Can you do the next one as well? How many sig fig is that?
Yes, it also has 3 significant figures, because the zeros to the left, we don't count them.
Okay, how do you know this? Is it from high school or from a previous science lab you took?
I took it in analytical chemistry.
Okay, awesome. I love this. Please, Noha, at any moment, if you believe data analysis for physics is a bit different than chemistry, let me know. They should merge eventually following the same rules, but sometimes they don't, and I don't like this. So if you ever see any difference, let me know, and we can together merge rules into one. Okay, that's good for you. Yara, can I ask?
Okay, thank you. Actually, I'm taking the course right now.
Okay, so great. So you're learning on both levels, I suppose. May I ask Yara about the next two? Yara, how many significant figures you have for this one?
2.
And how about this one?
1.
All right, so basically zeros on the left are not counted. Zeros on the right are counted only when I have a decimal, and zeros between the digits like this one is always counted. Thank you, Yara. Ali, can we do the next 3? Yes, Ali, are you there? No? Anthony? Probably Anthony can help me. Come on, boy.
Yes.
Okay, so how many sig fig is that?
4.
4 sig figs. And the next one?
3.
Only 1 actually, because 5.
5.
This can be written as 5 times 10 to the 2. And the zeros here are not significant. They are on the right, yes, but there's no decimal point. I don't count them. However, the next one is?
4.
4 significant figures. Awesome. Let me save as this file so we can keep it, because I want to share this with you, not the original one, obviously. Okay. Now
I have a question.
Yes, who has a question? Andrew? Okay, Andrew, this one was confusing for you, right?
No. بتسألك عن 0.5 لأنه بكل الكورسز عندي نفس السؤال وما وصلت لجواب.
Okay, so 0.5 or 0.50?
Yes. Why can't we just write it 0.5 times 10 power whatever? And why need the 0 after it?
This is a very good question, by the way. So 0.50 actually is different than 0.5, because you need to understand these are measurements, and measurements do fluctuate. I mean by fluctuate, when I read 0.5, it could be 0.4 or 0.6. By fluctuation, it could be the measuring tool itself or the way you're measuring. Okay, so when I communicate 0.5 for someone, I would say 0.5 could be 0.6, could be 0.4. Okay, depending on many parameters. But if I ever say it's 0.50, it means it would fluctuate between 0.49 and 0.51. And as you can see, it has a smaller margin of fluctuation. So it's as if I'm saying this digit fluctuate, but this one I'm very sure about. Here I'm saying this one is fluctuating. So I'm just telling I don't know, the person who's reading my lab report, which digit is actually I'm very sure about and which digit I'm not so sure about. So adding a 0 is only to tell or to give information that this is more precise than this one. And this one contains more information than this one. You see what I mean? Probably, Andrew, I did not convince you a lot.
لا you did. أنا فهمتك.
Okay, you need to understand something that I'm facing with my students, you or high schoolers. You've been dealing with numbers since you were 2 years old, I suppose. And numbers since then were only numerical values. They were never measurement until now or until you turned 17 years old. So it took you 15 years old, the 15 years to understand values, and now sometimes we cannot convince you in a month or two the difference between numerical values and measurements. So Andrew, I totally feel your confusion. It will take you time. هلا أنت فهمت, I know, but other students it may take you a few weeks to grasp those concepts. This is a little bit confusing for you. I totally understand. Now the rules. You need to understand that in between zeros are counted. Non-zero digits are always counted. Trailing zeros are counted only if you have a decimal point. Like in this case, you do count them. Leading zeros, or what you call the zeros on the left, are never counted. Okay? And you can see the rules here. Just read them. You can find them anywhere. Google them on YouTube. Now, an example for you. The rules are still here. Probably I can ask more students. I know I'm taking some time, so probably Fadi can do them all in one shot. Fadi, can you help us, please?
Yes, doctor.
All right. How many sig figs?
5.
Next. How many sig figs?
4.
Next.
4.
How many sig figs?
5.
Then, how many sig figs?
3.
Wow, شو سريع وهيدي.
2.
وهيدي 2. Awesome. I do agree with all of these. Please let me know if you don't agree and if you have any question. All right. Next. Now we're on item 2 measurements. Yes.
Doctor?
Yes, Aya.
بنت واحدة ليش 5 مش 6؟
All right. So basically, so sorry to tell you, just a second, that this is a comma and not a decimal point. And a comma means a thousand.
Sorry.
Yes, I know that was confusing.
That's why.
Yeah, I know. It's my bad. All right. I'm happy we agree on this one. All right. Measuring tools. I need someone, and probably we're talking to Karen. Karen, how many types of measuring tools do we have? Or you can give me examples if you want. Measuring tools. Any measuring tools, Karen, you used this morning? Is Karen there? Yes. Say it again.
I didn't hear you. Can you repeat?
All right. So which measuring tool did you use this morning? Give me examples. Anything.
A ruler.
Anything else? More examples.
A beaker.
That's a good measuring tool. Anything else?
A pipette.
I used a thermometer in my car. I wanted to see the temperature. Did you say? I heard.
I said a pipette.
Did you use a pipette this morning at home?
No, but it was in the chem lecture.
Okay, so it was a virtual pipette. Is that how I spell pipette? This is so weird for me. I never used a pipette in my daily life. I used a bathroom scale. I wanted to know my mass. All right, probably I can ask Eli. Eli, did you use any measuring tool? I'm talking like really daily life measuring tool, not like pipette. I used a spoon actually, you know, because I wanted to make coffee. Any measuring tool?
Yeah, exactly. I was going to say a glass of water
Okay, it
or
can be
a
cup.
stopwatch or whatever.
Yeah, stopwatch. To time, I don't know how long a plank can be done in the morning. All right. So now, Ellie, stay with me. I want you to split those measuring tools into types. And basically, we're going to have two types of measuring tools. Can you see anything similar? How many types of measuring tools do we have? I'm going to help you. The first one is digital. And the other one is analog. So Ellie, probably you can tell me which of those is analog.
A thermometer can be analog. A ruler is definitely analog. A pipette beaker analog. A bathroom scale is digital. Spoon is analog. Cup is analog. Stopwatch is digital.
Okay, so the point is to see the difference between analog and digital. And you can have the same being analog and digital. Stopwatch can be analog. Bathroom scale can be analog. Thermometer can. But a cup is definitely analog. A spoon. Yeah, and you can see each of which has different precision. A cup and a spoon and a pipette and a beaker, they all measure volume, right? But they have different precisions. And this is the need to study, what is it called? Uncertainties. Now I'm gonna take a measurement one. I forgot what I wanted to do, using a digital measuring tool, all right? So let's say my neighbor measured her mass, and the mass is 52.0 kilogram. This is my neighbor. I want to know the uncertainty on this value. Probably ask Karel to help me. So Karel, I took a measurement done by my neighbor. It's the measurement of her own mass. And the question is, what's the uncertainty on this measurement? Karel. Is Karel there? Not? Okay.
I'm here.
Okay, Karel. Karel, together, I know probably you don't know the answer, but we can make sense using common sense. We have a digital measuring tool, which is the bathroom scale. And this is the measurement we did. And the question is, can you guess what is the uncertainty on this measurement?
The answer here is more precise because you have the digital 0.
Okay. Did
But
you say
we
more
can think that the answer. Yes.
Okay.
But the uncertainty here may be that the value can fluctuate between 51.9 or 52.1.
All right. So the uncertainty, the range is 0.2. Uncertainty is the range divided by 2. So it's basically 0.1. So you're saying it's 0.1 kilograms, right?
Yes.
All right. So it's the smallest reading, in other words. Let's take it as a rule, okay? So every time you have a digital measuring tool, you take the smallest reading, which is here 0.1, to be on your uncertainty. And it makes so much sense to Karel, which was using common sense. I'm gonna ask Anthony to use the ruler that is here, which is an analog measuring tool, so analog measuring tool, to be able to do the actual measurements. So length equals. Anthony, are you with us?
Yes.
Okay. Yeah, I remember your voice. Do I know you, Anthony? No?
I don't think so.
Okay, but because you sound like a student I have, and his name is Anthony as well. All right. So Anthony, can we do the measurement here? The length of the red line. Try. Easy.
23 millimeters.
Okay, you want to use millimeters, and I'm gonna respect that, millimeters. Now let us try to write the uncertainty. I need to give you a hint though. The uncertainty on an analog measuring tool is the smallest subdivision, okay, divided by 2, because I can estimate half of it. When you look at the smallest subdivision, which is here 1 millimeter, I can tell probably half, but I cannot say probably 1/4. Okay, so what is the smallest subdivision on this measuring tool?
0.5 millimeter.
Okay, you divided it by 2, right? So 1 millimeter divided by 2 is equal to 0.5 millimeter. Now I want you to count how many decimal is your uncertainty.
1.
1 decimal. This one should be 1 decimal as well. Can you please fix it with more information? It has to be 23.0 if you want. If you want to say 0.2, it's also possible. Anything you want. Just put more information just to say that this one you're sure about. Okay? How about you look again at the figure? This is 23. Do you want to put 23.0 or anything else?
23.0.
Say it again.
23.0.
Okay, but I see it's a little bit more than 0.0. Although you have the right to say so. But isn't it close?
Let's put 0.1.
Okay, so as you can see, I cannot fight with Anthony upon this because we are still within the margin of error. So if Anthony is your partner and he wants to write 23.0 and you would want to write 23.4, both are acceptable because you're still within the margin of error. But do not write 23. 23 would give you information that fluctuation is happening between 22 and 24, which is not true. Fluctuation is happening between 23.0 and 23.9, you know? So this is the margin of fluctuation. Black is not a great idea. Let me go back to white. Okay, so now what is the rule and how do we deal with it? For an analog measuring tool, the uncertainty is the smallest subdivision divided by 2. For a digital measuring tool, it's the smallest reading, period. You don't divide by 2. What just happened? Nothing. It's not my laptop. All right. So always make sure that the uncertainty is one significant figure, which is, let me use a red pen to show you. And we need it really thick because I zoomed out a lot, by the way. So this is the uncertainty. It's one significant figure. Awesome. The uncertainty is one significant figure. Awesome. Now I look at the measurement and the uncertainty. Do they have the same precision? 1 decimal, 1 decimal, awesome. Do they have the same precision? 1 decimal, 1 decimal, great. Otherwise, I need to add digits. So do not give less digits than needed, neither more digits than needed. Oh, this is Layal raising her hand. Yes, Layal, you had a question.
Doctor, I'm Layla.
Layla,
Anyways,
Layla, yes, yeah, Layla.
So we took in centimeters. Will the answer be the same as in centimeters or different?
Let's do it together. This would be 2.31 centimeters, okay, plus or minus 0.05 centimeters. Am I right?
Why 31?
Because Anthony wants this.
Okay.
All right. In other words, he has the right to, because you are within the margin of error. Personally, I would say 2.35. I'm sure you would want to say 2.34. All measurements are okay because you are within the smallest subdivision divided by 2. Okay. I know it's awkward to say 1. ما بعرف ليه أنتوني شايفها 1 بس أنا ما فيني شارعه لأنه he's estimating. That's the point. Did I answer your question, Layla? Let me know, okay?
Miss Jessie?
Yes, Yara. By the way, Yara was few minutes
behind us.
Yeah.
Yara is your daughter, right?
Yeah, and she was stealing chocolate, but I didn't want to make a big deal in front of you. Yes.
Yeah, I wanted to ask you, will you send us the PowerPoint with the answers?
Yes, why not? Yes, why not? So this is why I saved as, and this is only for your class, because the other class may ask different questions. So yes, I'm gonna send you the PowerPoint with my writings on, along with the recorded
Okay,
session.
thank you.
Yeah, for you to listen to it again. All right, so again, we have different types of error, one of which is the instrumental error. So I'm discussing the uncertainties on the measurements. I want you to look at this example. You see two rulers, two analog measuring tools. They have different units and different smallest subdivision. Look at this one. I love this one. When I was back in high school, we had to purchase a ruler that has the smallest subdivision to be not 1 millimeter, but half of it. It had a special name and we had to go and find it in the bookstore. Semi-millimetre. So you see the smallest subdivision here is this. Only the smallest subdivision is basically different. So every measuring tool has a different smallest subdivision. You see? So the smallest subdivision is only the smallest whatsoever. Next, so these are examples. Just a second, because my file is overwhelmed. I'm zooming out. Okay. Now your turn to think about the smallest subdivision. Probably you can keep this as an assignment that is not graded, but it will help you probably learn to turn in or not. So probably I would put an item where you can turn in or submit your assignment. And the assignment could be one slide of like this one. And probably I can give you the answer sheet later to correct yourself. So this is not graded, it's only to give you a certain routine. Before I leave you to do this on your own, I can ask Priscilla. Priscilla, I know you, right?
Hi, Dr. No.
Okay. I'm too old, I can't remember names well. All right, I just want to ask you, is this an analog or a digital measuring tool?
Analog.
Okay, what about this one, analog or digital measuring tool?
Digital.
And what about this one, analog or digital measuring tool?
Analog.
Okay, it says here that half the smallest subdivision is your uncertainty. And it says here for a digital instrument, the uncertainty is only the smallest subdivision. Priscilla, do you think you can do this on your own in the afternoon?
Yes.
Okay, I'm gonna give you some time to try it. Now we're moving to something new, or this is to wrap up measurements. Every time you have an uncertainty, make sure it's one significant figure. Don't forget to add the unit, because as you can see with Anthony, he wanted to use millimeters and another students would want to use centimeters. So please write a unit so we understand what you mean. And the measurement must have the same number of decimals as the uncertainty on it, which means add zeros or remove zeros, just round according to same precision for both. The uncertainty tells you how precise you should go. Now we can start with averages. So let me go back to the outline. What we did so far is 1, 2, we still have 3 and 4. Now back to averages. This old man, I don't know if you ever saw this old man before, is measuring his own mass. He did those measurements and like 3 different trials. I mean by trials, the same experiment done repeatedly, same day, same everything. And we need to find the average. The question is for Layla. Layla, why do you believe we need to find the average? So why do we need to find the average? Back to Layla. Yara is here again. She wants a cup of water. Layla, are you there?
Yes, doctor, but it's lagging.
Okay. All right. If it keeps on lagging, let me know. So my question is, why do we need to find the average? And why do you think the man took his mass 3 times?
To be more precise.
All right. To increase precision. Precision or accuracy? Do you know the difference?
Accuracy.
I would say precision, because who knows about accuracy? Probably all these values are far from the true value. But anyway, it would give me more information. Let me call it more information. Do you know how to find the average, Layla?
Yes, we add them and divide them by 3.
Okay, so this is the rule for it. It says X bar, which is the average, is actually you do sigma means you add them all and you divide by n. N is the number of measurements. So you do understand this equation to find the average. Now, how do we guess the error on the average? Have you ever done this before?
Yes, in Chem 301. Sorry.
Okay, how do you do it? Can you tell me a bit what do you do, what do you call it, anything?
We find the standard deviation.
The standard deviation, okay. In our case in physics, we're not gonna find the standard deviation. We're gonna find, by the way, this is RMS. So alpha RMS. I know this is frustrating. It was frustrating for me. I was like, why in chemistry we do standard deviation and why in physics do we do RMS? By the way, the standard deviation is the same exact thing without the n. And I found out that it doesn't matter if you do RMS or standard deviation, both will give you how far away the scattering is. And if we are dealing with a big number of measurements, above 100 and 200 repetitions, it will not be a big deal, or probably because we have a small sample, that's why it's no different. Anyway, in physics, we deal with the alpha RMS, which is very similar to the standard deviation. You only need to add an n. Okay, I suppose who was talking to me, Eli? Eli, can you explain what DI represent?
The deviation from the mean.
And how do you find the deviation? Let's do this one together.
Each value?
Yeah, can you find the average for this one using a simple calculator? So I'm gonna call it M bar.
Yeah, sure. 1 sec, 89.6. 89.3.
Exactly 0.3?
Yeah.
Okay, any unit?
Kilograms of heat.
Okay, now how do you find D1?
Right, you subtract 89.4 minus 89.3.
And so it's M1 minus M bar. Okay, now going back to the equation, what does sigma di squared represent? It represents D1 squared plus D2 squared plus D3 squared and so on. Okay, so you square each and then you add them together. That would be sigma. N into n minus 1. In this case, n is equal to 3. Probably I'm going to write it here. N is equal to 3. It's the number of measurements. So n minus 1 is going to be 2. By the way, nobody does only 3 trials. This is only an example. We usually do more. And you compute everything to find alpha RMS. When you finish, don't forget to round to one sig figure uncertainty, because alpha RMS is also an uncertainty. It's just a different type. Make sure it has a unit and make sure the number of decimals of the measurement itself, which is this one, this should be the same number of decimals as the uncertainty itself. Okay, probably I need to give you a few minutes to give me the alpha RMS. Everyone, please grab a calculator. Let me take a screenshot of this one. And let's do the RMS of this one. I'm just curious to see if we end up with the same answer. Okay, so a few minutes, I'm gonna be quiet. This is the equation for you. I need alpha RMS. Even for the newcomers, I want you to try. Please speak up if you have an answer.
طلع 0.2.
Okay, I'm gonna write your answer. I assume kilograms. I can see some questions in the chat. The most important one is a beaker. The smallest line indicates a milliliter. So the smallest subdivision is a milliliter, I suppose. Imad, are you still confused about what we mean by the smallest subdivision? Imad, are you there?
Yes, doctor.
Do you?
Yes, بعد شوية عمرية هي شو يعني أصلا؟
Okay, so the smallest. Okay, let's read it here. Can you tell me what is the smallest subdivision here? The ruler. This one. The smallest box.
0.5
unit.
centimeters.
Okay, شوف لي هون قد ايه بتطلع. Is it clear? Okay, let me remove the chat. So you have between 30 and 40, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. So each jump is how many?
واحدة.
1 degree C. So this is the smallest subdivision, like the tiniest jump you can read. Okay.
Okay.
All right, now back to your answers. I can see a lot of students. Did you do square root of the final answer? How come you have 0.2 and 0.3 and 0.28 and 0.208? We have a mistake somewhere.
Yes, doctor.
I think it's a calculation mistake. Which one shall I trust? And can you round your answer to 1 sig fig? Let me see Ali. Ali, are you there? Imad, do you have an answer for the RMS?
دكتور أنا طلع معي كمان دسم بس كتير دسم بس طلع معي بس أنا بدي أعمل راوند بالسيك في حسب بدي أعد بس أنا بتاخد كتير وقت بس ما أقعد أعد إنه كل أوبريشن قد إيه فبتاخد كتير وقت يعني.
أوكي ما فينا نحط مثلا كل شيء between parentheses squared و in one click on the calculator click وتظبط؟
بقى إيه بس إنه هتاخد وقت من إيدي هلا خلينا نرجع.
Okay, Imad, I believe you. And I need to tell you something. Never use this equation. That's the point. It's time consuming. There's a way your calculator can give you the answer directly. Let's assume it's 0.2. Make sure you round it to 1 sig fig. Make sure you put a unit. And make sure to think that's 1 decimal. This should be 1 decimal too. Otherwise, you need to fix your average to make it 1 decimal as well. All right, so since you guys are not happy with the equation, personally, I'm not happy with the equation as well. In this YouTube video, it shows you how to use your calculator. So back to the link, how to use the calculator, which is a regular Casio calculator, to go into the mode stat and to find the RMS value in 1 click. But be careful, the calculator will not do the rounding for you. When you get the final answer, make sure to round to 1 sig fig. We can watch the video together or you can watch it later. I think watching it later is much better. Probably you will see in the YouTube video a calculator different than yours. This is where I urge you to learn how to use your own calculator. And if you don't know, please meet with me. Give me what calculator you have and we can do it together, okay? So everybody in this class should learn how to do the RMS in 1 click on the calculator. You just plug in the values, it will give you the average and the RMS in 1 shot. Okay, fair enough? All right, now this is an assignment you can try on your own. So I will show you how to submit later, probably write an announcement about it. You are given random values of a temperature of a child. And I'm sorry to jump. And then you have to find the average. So find T average equals question mark, and then find the alpha T, which is the uncertainty on T, or what we call the RMS value. Make sure you round well, it's very important. Make sure you put units, make sure you learn how to use your calculator. So this is also not graded, it's only to push you to try on your own and to make sure you tick it out of your list, you know how to do it. Questions, yes?
Doctor, and the average and the RMS should have the same decimal places, like also in chemistry?
Yes, exactly. But make sure you round your error first, then the average. So the average must follow the uncertainty and not the other way around. So fix your uncertainty first, then fix your average. Okay, it's very important for the uncertainty to be 1 sig fig. All right, now I'm gonna jump for the calculated value. We're studying this law. Have you ever heard of this law, the famous?
Yes, Newton's law.
Yes, Newton's second law, obviously. M is measured. My neighbor actually measured M. She did the measurement. I don't know how. I did not ask her. Digital measuring tool, analog measuring tool. I have no idea. She has the uncertainty. I also have no idea how she got it. I'm happy to see units. I'm happy to see one significant figure, and I'm happy to see that the decimals do actually match. She's a professional. She knows what she's doing. Another neighbor did the measurement of the acceleration. By the way, we're talking about the apple, if I'm not wrong. Yeah, doesn't matter. Mass of the apple. The apple cannot be 15 kilos though, so it could be anything. The acceleration of the object and the uncertainty on it. Now my job is to calculate F. Probably ask John. John, what would be the value for F? Yes, John. Ellie, you're so funny. You believe if Newton would go, somebody else would come? Probably somebody worse than Newton. What's wrong with Pia? Pia has the same discussion, same inside.
Well, Pia went viral on TikTok because she made a TikTok video about Newton, and it was so funny. So that's why.
How can I see the video?
I'll send you the link in the chat, maybe.
Please, is Pia with us? She's not in this group?
I don't think so. I don't know, because if she was, she'd instantly reply.
Yeah. By the way, Newton is my favorite. So now you're like picking on my, I'm gonna take it so personal. So anyway, so back to John. John, are you there?
Yes.
Doctor, are you talking?
Yes, just a second. Jane, you have a question?
No, doctor, sorry, I thought you were talking to me.
Okay, I'm sorry. All right, just call me Jessie, okay? It's awkward when you say doctor. So back to you, John. The question is to find F. How do you calculate F? Do you have an answer for me?
Yes, I multiply A by M, and it's 37.26.
Okay, let me write the final answer. 37.6 or 26?
0.26.
Okay, unit?
Newtons.
Okay, you can say newtons, you can say kilogram meter per second squared, it's also newtons. Now the question, how do we find the uncertainty on F? Do you have an idea?
Not sure.
All right, so Jane, your answer is different than John. You guys, you're confusing me. I'm gonna use my phone because my calculator is far. I'm gonna do 2.2 times 15.8 and I get 34.75. John. Okay, it's okay, it happens. So it's 34. We don't want to confuse everybody, John. 76, am I right? Please let me know. Now the chat is open, so I don't want to miss anyone. How do we find the uncertainty on F? F is not a single measurement. F is not an average. F is a calculated value. So the error, don't we have F is equal to MA? Let me use a different color. Now the error on M will propagate through F, and the error on A will propagate through F following a certain function. So we need to do the propagation of error. I've never written it here. I would really want you to know the name for it. Let me call it propagation of error in bold. So propagation of error. So this is the method I'm gonna follow right now. How do we follow this method? I want you to look at the equation with this equation well, and let me try to explain what each term represents. So this is the derivative of F with respect to one parameter X. We call it partial derivative, but don't worry about it. It's regular derivative. Just take your X to be the variable. F is the function. This is another derivative if I take Y to be my variable. And this is another derivative if I take Z to be my variable. Now the function that I have here is a function of two variables, M and A. So two different variables only. I'm going to do the derivative of the function F. It's a function, by the way. You can see multiplication, right? It could be division, it could be square root, it could be sine, cosine, 1 over. It's a function eventually. So multiplication is a way, it's a type of function. So I'm going to do the derivative of this taking a to be my variable. Then I'm gonna do the derivative of my function, taking m to be my variable. Probably ask Rhea to help me. And Rhea, if you do mistakes, it's okay. This could be confusing. What is the derivative? Yes, Rhea?
Yeah. But I forgot how to do derivatives.
All right, so a is my variable. I'm gonna replace m by a constant 2. What's the derivative of 2a?
I don't know, I forgot. It's been a long time.
2x. What's the derivative of 2x? All right, a quick reminder for Rhea, if you have a constant, the derivative of is 0. If you have constant times x, the derivative is constant. And if you do forget this, it's okay. Just ask me to remind you, okay? So 2 is a constant, a is your variable. That's why I wrote constant times x being the variable. So the derivative of the function f with respect to a is actually m. Can you try Rhea as well? Because I know Rhea is a bit confused. What would be the derivative of the same function if m is my variable now and this is a constant?
It would be m.
It's gonna be the constant itself, which is called a in this case. All right, I know you're not happy, I know you don't like it. Please, Rhea, every time you need to do a derivative, come back to me and ask me to do it for you, okay? It's okay, we're not doing math here, we're doing physics lab, and you have all the right to say, listen, Jessie, I don't know how to do it for me, okay? Eventually, you're gonna know how to do it yourself. So you plug in, so it's gonna be m, I'm plugging in the values, error on a, all of it squared, and then you continue times a, plus a times error on m, all of it squared, and then you're gonna do the whole square root. You have everything you want, a, yes, Jane, give me a moment, the error on m, and the error on a, just plug in the values, do the calculation, the calculator does the work for you. When you finish, make sure you round this to 1 sig fig, add a unit for it, and then round your value for m. Where is it? The value for f accordingly. So when you have this one, they should have the same number of decimals. Probably I need to add a 0 or not. Probably I need to round up and remove the 6, and this is going to be 34.8. I don't know, depending on the error itself. Yeah, probably we can try it right now if we can. Jane, you had a question?
Yes, doctor, I just wanted to ask, will we get the same uncertainty after if we do it in another way, which is the relative percentage uncertainty, and then we just find it for the
the one you use in chemistry? I believe you should get the same answer. All right.
Okay.
Unfortunately, in chemistry, they teach you how to do it for multiplication, division, plus and minus. They never ever explain how to do it for sine, cosine, probably 1 over exponential, and so that's why this is very general. Okay, Jane, can you help me? Yes. Aya, which part you want me to repeat? This one?
Yes, this one.
I can give you another example, because if I repeat the same exact example, you're going to be even more confused. But before I move there, Aya, let me go back to Jane. Jane, help me find the calculation for alpha f. Okay, so what I'm going to do is I'm going to change the thickness of my pen, and I'm going to zoom in. I just need space. And I'm going to write alpha f is equal to m, which is 15.8. You just need to handle your calculator, that's all, times alpha a, which is 0.1. Okay, you're doing it on your calculator, I suppose. Plus,
yes,
and
doctor,
please everybody do this, because we don't need to trust one student. We can do mistakes. A times alpha m. Just a second. Old Jessie would do mistakes. 0.4, all of it squared. And let's do the square root. So Jane, you have an answer. Please round your answer to 1 sig fig, because we need to keep an answer for the sake of the slide. Yes?
Doctor, I got 1.8, which is approximately 2.
Okay, I'm gonna say 2. Now go back to the previous slide, which is this one. I'm gonna say the error is 2. So probably write that my f is, how can I round this one? 2 has no decimals, so this should have no decimals at all. How do you round this?
it becomes
35.
Okay, so it's gonna be 35 plus or minus 2, all of it newtons. Or you can write newtons twice, 1 for each. All right, yeah. So now back to yeah, let me see, Eli. I got the same error following the chemistry method. Thank you, Eli. I wanted this for confidence. I know we should get the same answer. By the way, the chemistry method is the method I teach my IB students to use because it's IB official. I never had the chance to try it. Probably I tried it once, but I know for a fact they should give you the same answers. Okay, now let me give Aya another example. This is an example that you should try on your own as an assignment that is not graded, but probably I can add a slide at the end of our section, any random slide, and create any random function. We can ask Sarah. I did not talk to Sarah today.
Hi, doctor.
Hi. Give me any function you use in physics. I would want to say chemistry, but I would freak out when I see the chemistry equations. Anything you
You're asking the wrong person. I forgot half of them.
All right. So I'm going to give you something that is not too difficult. Acceleration on an incline is g sine theta. I want to include sine to show you that you cannot always use the chemistry equation. I wanted, or probably, let me use simply 1 over. Any equation that has 1 over. Whatever, let me call it A is B over C. Okay? And the question is, Aya, I need you to help me to find the error on A. Okay?
Yes, doctor.
So to find the error on A, first we need to do the derivative of A, taking B to be my variable. So this is my variable. So it's X over constant. What's the derivative? X over constant.
Constant.
It's 1 over constant. Let me write it for you. X over constant. The derivative is 1 over 3. Okay. Times the error on the variable itself. Done with the first parenthesis. Now the second one. I want you to do the derivative knowing that C now is the variable.
So it's T.
So it's like 3 over X. What's the derivative of 3 over X?
3?
It's minus 3 over X squared.
Okay.
Okay, I'm so sorry. I know you forgot those. I know you guys probably graduated high school a long time ago, or am I wrong? Okay, let me not write 3. I'm going to write minus B over C squared times alpha C. Okay?
Okay.
And the same applies if you have sine or square root or anything you want. All right, now let me move our camera and the chat and probably write those in a different way so you guys can keep it. This prime is gonna be 1 over 3, okay? And if I have 3 over X, the derivative is of this guy is, the derivative is minus 3 over X squared. I just want you to keep it eventually. Okay, and probably we're gonna keep this in a box, okay, because I can see that my slide is a bit messy. All right, anyway, if you ever need help with derivatives, especially for the first few weeks, let me know, I can do it for you. All right, so far, how many assignments do we have? How many slides as assignments? We had this one, but we did it together. You can take a screenshot. This one is also an assignment for us. Yes, you can take a screenshot, but you don't have to since I'm gonna share them later. But screenshot mean you can do it now because I'm slow sharing stuff. Probably I'm gonna wait until the evening to share. We can do this one as well. So this is slide number 2 to do. You can take a screenshot. And this is slide number 3 to try. So 3 slides to do on your own. They are simple applications just to make sure you grasp the idea and to let you know if you got it or not. The point is not to grade you again. The point is for you to make sure you're done with the 4 first items of data analysis. Cool? That's it for today. I have no idea if we went fast or slow. I'm gonna discover later when I discover إنه ما حدا فهم شيء. شو? Tell me.
Jessie?
Yes?
Yes.
Yes?
Can you please go to slide number 14?
Okay, this one. You want to take a screenshot or do you want to ask a question?
Yes, please. Can we solve the formula?
Of course. By the way, you just reminded
Thank
me.
you.
Yeah, we have a document. Probably I can show it to you. Where can I find it? Let me show you. Probably fall 2020. I'm going to share something very similar with you for the students who already did physics 306. Probably here. Let me show you. The first, you have a chapter called data analysis. By the way, I've written it myself. Okay. Introduction to error analysis. I think I can click. And by the way, it's the first chapter, no need to click. All right, so it gives you a lot of readings to do, not a lot, but some reading to do. Okay, so it gives you the equations that you need to use. It explains a bit how you do the smallest subdivision divided by 2. Something related to accuracy and precision, because we did not discuss this thoroughly. I suppose you know them from high school or not, but we're gonna discuss them again. Standard deviation and RMS, propagation of error, and we need to continue through graph skills and slope, and you have some references. And again, if you believe things are not clear to you, you can at any moment find anything you want on Google or YouTube, okay? Because this is general and this should apply to any science, I hope. All right, so can you share slide 8 and 12 again? So this is slide number 8, which is number 8. Yes. You want to take a screenshot, I suppose, but I promise tonight I'm gonna put everything on this on the Google on the Blackboard, okay? And this is slide number 12 for Priscilla.
Thank you.
All right, you are dismissed. Unless you have a question, you can stay. Anthony, alpha is actually the uncertainty. So when we say alpha on M, it's the uncertainty of M. All right, so if you have any questions, simply stay behind and let me know. I'm gonna stop recording the session now.